So the second part of this problem, we have to perform the stoichiometry because ultimately we're looking for what the concentration of our potassium dichromate solution was. So in this titration, our sample is a 25 ml sample of the acidic 0.1 mole per liter tin 2 chloride. Our titrant then was the potassium dichromate, which required an average of 12.7 milliliters to reach the endpoint with our sample of tin 2 chloride. So write out the information that we're given. The tin 2 chloride solution had a concentration of 0.1 mole per liter. So this concentration is going to go here with my tin 2 ions, which are part of the tin 2 chloride. So 0.100 moles per 1 liter. And the volume that I required is 25 mils for each. I'm trying to find the concentration of the dichromate solutions. That's this guy here. And the volume that we used on average was 12.7 mils. So while we're solving for the concentration of Cr2O7, our dichromate, that means that at the end, our units that we want to end up with, so after we've performed our unit analysis with the stoichiometry, we want to have our final answer in moles per liter of the dichromate. So start with your known substance, which is the thing that you have the information for. Our unknown is what we're looking for. So I'm looking for the concentration of this guy. So my first step is to take the substance that I have more information about and convert that into moles. So I know that the concentration is 0.100 moles of tin 2 plus per liter of tin 2 plus. I like to always include what it is that these units belong to so that I don't get confused during the unit analysis. So this is a good idea always to write the entity that this is referring to. I want to convert this to moles, so that means I have to cancel out liters to leave me with moles of tin 2. So if I want to cancel liters, and liters are here in the denominator, I've got to put liters of tin 2 in the numerator to cancel. My volume, if I convert that to liters, is 0.025 liters. Fill in the empty spaces with a 1 just so we can keep everything looking like a nice fraction. This is the step where we use our mole ratio. So I've canceled liters of tin 2, and I'm left now with moles of tin 2. So I want to convert moles of tin 2 to moles of dichromate. So if I want to cancel moles of tin 2, they've got to be down here in the denominator, and then moles of the dichromate are in the numerator. The coefficient of dichromate is 1, coefficient of tin 2 is 3, so my mole ratio is 1 over 3. Moles of tin 2 will cancel. Remember that we're trying to solve for concentration, so we want moles per liter of dichromate. I've already got the moles of dichromate here, but I need it to be per liter. So if I want moles over liters, I need liters of dichromate in the denominator. And the volume that we used was 12.7 milliliters, which is 0.0127 liters of dichromate. Fill in the empty space with a 1. And we end up with our units, moles per liter. You can type this in your calculator exactly as it's appeared here as long as you make sure you include the brackets. And you should get an answer of 0.0656 mole per liter. Another way we could write that is 6.56 times 10 to the minus 2 moles per liter.